Well, good morning, everybody. You don't get me with a tie today because it's supposed to storm today, and I never like to walk around campus in ties and dress shoes when it's supposed to storm. It just doesn't work out well for me, so you got me on a kind of a Friday on Wednesday kind of look. So today we're going to talk about two important topics. One, we're going to start off with the scientific method, as you might imagine from what you're seeing on the Word document there. And the second is ethics. Now, both of these topics are important for you, regardless of whether or not you remain a chemistry or biochemistry major, or even in the sciences. The scientific method is what makes science science. It is what separates science from other disciplines. Okay, now you all may think that there is the discipline of biology, and there's the discipline of chemistry, and there's the discipline of physics, and there's the discipline of whatever. They're all sciences. Okay, we break up into smaller units just largely out of administrative convenience. Okay? But the reality is that we only have one scientific method. It's also the reality that I've noticed over a long period of time that many students, when they get ready to graduate from high school and then when they get ready to graduate from college, still don't fully appreciate the scientific method. And so that's why I decided to incorporate that into this class. And we've been talking about it for several years that I've been teaching. So I always devote a lecture to the scientific method. And then I incorporate a little ethics in with it. A little ethics, as if there's any such thing as a little ethics, right? When you all think about the word, not scientific method, but the word scientific, what do you all think about? Experiments. Okay. What else do you think about? Doing something methodically. Okay. Very good. So we got experiments. We got doing things methodically. What else might you be thinking about? Pardon? Critical thinking. Very good. What else? What else might you be thinking about? Let me change the topic just a little bit. What might the popular media be telling you about scientific? What might you be seeing on commercials or popular shows on television? What might the popular media be trying to sell you as scientific? You know, even when you're watching CSI, you're not getting much of the scientific method, right? What the popular media and everybody tries to sell you as scientific is actually technical. Fancy toys, right? Solving the crime. It's built into your DNA. Right? Or a lot of companies these days will say, you know, we do X, Y, and Z. It's built into our DNA. They're trying to sell you a bunch of baloney, really, is what they're trying to sell you. The scientific method is old, and it's reliable. Okay? And it is the same scientific method if you're in biology, chemistry, physics, anthropology, whatever the case may be. You all need to think about the scientific method anytime you are asked to critically evaluate anything. The politicians, the media, everybody is going to try to get across their agenda to you. That's just life. And you need to use the scientific method to try to figure out whether or not, you know, what they're feeding you is baloney. The scientific method is your BS detector. Okay? You will hear things that just sound right, and you'll believe them. And you need to critically think about that. Because just because something sounds right doesn't make it so, right? And that's what the scientific method allows us to do. It gives us a methodical process by which we can determine if something's baloney. If I wasn't in class, I'd probably use a different word. But you get the idea, right? So, regardless of where you stand in your major, the scientific method is important for an informed citizenry to make informed decisions about anything. Okay? You should always be a critical thinker about anything, whether it aligns with your religion, politics, personal beliefs, whatever. You need to be a critical thinker. It's the one thing that you should leave college with. If you forget everything else that you've ever learned in college, don't forget about the scientific method and how to apply it in everyday life. That's what the video was about, right? The video talked about applying the scientific method to finding your cell phone, the most boring thing in the world, right? Because now we can find our cell phones as long as we have our watch. We hit a little thing and it bing, bing, bings, right? And we can find our cell phone. All right. So let's see if we can't figure out what the steps to the scientific method are before we do the in-class activity. What's the very first step in the scientific method?
Problem.
Some type of problem, right? Usually we call this the observation, right? We observe something. I got a bottle with something in it that looks kind of weird. Things floating in the middle. That's an observation, okay? What happens after the observation? Is hypothesis the next one? We're going to formulate a question, right? Or a curiosity. Now, people will word the scientific method steps a little differently. Don't get too caught up in that. Right? Scientists are intrinsically curious people. When I poke that, it moves. Why does it move? Right? We're curious folks. What else? Pardon? We're going to have to form a hypothesis. But before we form, what is a hypothesis? It's an educated guess. So, before I can formulate a hypothesis, what do I need to have? I need to have a little education, right? So we typically try to do a little research. Right? What's known? Right? If it's already known, well, I'm done. I don't have to continue on, right? If I believe the stuff that I've read. Now what do? Yeah, we form a hypothesis. You all said that a hypothesis is an educated guess. Okay? Are all educated guesses hypotheses? Why not? It has to be testable. That is the difference between science and philosophy/religion. Okay? If it's not testable, it can't be scientific. Okay? And I'm not going to comment about the other things, but we're just talking about science, right? If you formulate a hypothesis and you determine I can't test that, then your hypothesis is not a hypothesis. A hypothesis must be testable. And what else must it be?
An if-then statement.
Pardon?
If-then.
Usually it's an if-then statement. Very good. What else? If this, then that, right? So we know if something is one way, then something else will follow. All hypotheses must not only be testable, but you must be able to prove them to be false. Okay? If you go into a laboratory and somebody tells you, we need to develop an experiment to prove our hypothesis, they're telling you the wrong thing. You must develop experiments that can disprove your hypothesis. Just because something seems to prove your hypothesis doesn't mean that it is true. But if I can develop something that is false, and it turns out to be false, I know my hypothesis is false. This is the difference between the physical and natural sciences and some of the other, dare I say, pseudosciences. People take that to be a negative thing, but if you ever read or watch some of Richard Feynman's talks about pseudoscience, he doesn't argue that they're not valid areas of study, okay? But a pseudoscience typically tries to prove a point. And you really can't. But you can disprove things, okay? All right, so we know what a hypothesis is, right? Now what do?
Experiment?
We experiment. Very important that we experiment, right? What kind of experiments can we do? Right? Well, we better be doing experiments that give us the information we need to know whether or not our hypothesis is false. And if we keep interrogating that hypothesis with multiple experiments, and in all cases, I wasn't able to prove that it's false, we can start to say that it looks like the evidence is that the hypothesis is true. Right? There's a difference between a hypothesis and a law. Right? So there are a lot of hypotheses out there. Do experiments. What kind of experiments do we do in chemistry? You probably haven't even had a lab yet where you were really testing a hypothesis. Right? You all, when you went into your Gen Chem lab, for those of you that went into your organic lab, right? You haven't tested any hypotheses. What were you doing? You were following a procedure, right? We were teaching you a technique. And I think that's a shame. We need to get you into the lab and give you a hypothesis to test. Actually, we need to let you come up with a hypothesis for something and test it, right? That's really what science is. Science isn't about going in and using burettes. That's all technical stuff. It's kind of the fun stuff, right? We like to add things and watch color changes and all that kind of thing. They're important methods. They are important techniques that you need to know, but they are not the scientific method themselves, right? You do a lot of experiments, but you do very little scientific method when you go into the undergraduate chemistry laboratories. You do very little scientific method when you go into your biology laboratories. You do essentially none when you go into your physics laboratories, okay? Your learning techniques and things. But you should be thinking about the scientific method along the way. And then 6, what do we do?
Observe the results of the experiment.
Okay, we might analyze the results, right? So let's say analysis. Then what? We report. Let's call that analysis/conclusions. Let's do that. Right? We draw conclusions. And then we report that information. Very, very important, that last step, if you're in the sciences. Okay? And we'll get to that when we talk about ethics. That's part of that gift economy thing that you read about, which I find very interesting. Scientists are in two economies, right? The commodity economy, obviously, but also the gift economy. And so for those of you who read that, I think you would have found that very interesting. So now we've got the scientific method. We're going to test this out a little bit. First 2 rows are going to be group 1. You all turn around and work with each other. You've got a bottle here with some stuff. Let's start making some observations. You all will be group 2. And you 3 will be group 3. Okay, so go ahead and turn around and make some observations on those bottles. Full of liquid? Don't be gentle with them. Interrogate it. Pass it around. Let everybody take a look at it. Get together and work together on it. What are some of the observations you're making?
White's always on top.
White's always on top, blue's always on bottom. Blue must be heavier. What else do we know? What else can we think about with the bottle?
It's a closed system.
It's a closed system. What else do we know? Or have we observed? Shake it up vigorously and watch the liquid. Just the liquid. Don't get distracted by the beads.
Oh, I messed it up.
Why does the white beads float all the way to the top, the blue beads sink all the way to the bottom, and then they come together? What's happening?
Oh my God.
I can't hear, I'm sorry. Is air getting trapped in the white beads? Okay, that's a question. Let's keep track of that. Keep track of the questions you're having. So he asked a question about, is air getting trapped in the white beads? Could we test that? Could we develop an experiment to test that? How could we develop an experiment to test that? How do you think we could test that question?
I don't have a good idea, but I just know that you can observe bubbles coming out when they're floating back down.
Okay, so you observed some bubbles. Okay, that's good. But I also know that the blue ones also have holes in them, right? So why would air not get into the blue ones? But I could test what you asked. I could fill the bottle completely full of liquid and have no air in it, right? And shake it up and see whether or not that would work. Okay, so we could test that.
No matter which way you turn the bottle, the white beads are always on top.
Always on the top. So what does that mean?
They're less dense.
Yeah, it's about density, isn't it? Right? So the white beads apparently are less dense than the blue beads, by at least a little bit. How can we test that?
Different solutions.
Yeah, we could put them in different solutions, right? We could also take out a white bead, figure out what its volume is, figure out what its mass is, and do the same thing for the blue bead, and we can determine whether or not that is true, right? Because what is density? Mass over unit volume, right? So we could figure that out pretty easily, right? That wouldn't be too hard to do. We could do that. You have to get in there and get into the liquid. Now, when I'm looking at that, is the bottle just one liquid?
No.
Look at that. How do you know? They're both clear, right? It's all clear. It looks homogeneous. Right? How do we know that there are two liquids in there? When I shake it up, right? Shake it up really vigorously. Everything gets mixed, and then I start to see it separate. If I look really carefully, It looks kind of cloudy and turbid, right? And the top starts to clear up, the bottom starts to clear up. And so there's two phases in there actually of liquids, right? And these liquids can mix, but then they separate. What do you know about liquids mixing? What'd you learn in high school? Some don't. What kind of liquids don't mix with each other? Oil and water, things that are very dissimilar, right? Well, these things mix and then separate, so they must be what? They must be fairly similar, right? Turns out it's isopropyl rubbing alcohol and water. Now wait a second, isopropyl rubbing alcohol and water, I buy that at Walmart as a mixture and it doesn't separate, right? So is it pure water? Maybe, maybe not. Can we test that?
Yeah.
How can we test that?
Blow it off and see if there's a residue.
Okay, yeah, so we could take some of the upper layer, we could take some of the lower layer, and we could interrogate it, right? We could do that pretty easily. We could test a lot of those things, right? So what's the hypothesis that we could come up with? Depends on what observation we're trying to answer, right? The observation of why the white ones go up and the blue ones go down, right? We had a hypothesis that the white ones take on air, right? And the blue ones don't. So we could test that hypothesis, right? We could remove all of the air. It's testable. We could prove it to be false. Okay? How could we test the identity of the liquids? What test could we do? I mean, I already told you what the liquids were, but what test could we do to show what they are? You do solubility tests? Well, we could do melting points, but with liquids, we typically don't do melting points, we do something else. We do boiling points, right? So we might be able to take some of the liquid from the top, some of the liquid from the bottom, and determine its boiling point. That would give us a physical identity of what the liquids are, right? And that information could be used to disprove, right, one of our hypotheses, right? If they both had the same boiling point, they're probably not different liquids, right? If we took a little bit from the top and we went down, took a little bit from the bottom, and they ended up having the same boiling point, then they're probably not different liquids. Okay? It's kind of hard to see, but if you look really carefully, you can sometimes see the layer boundary. So we know there's two liquids in there. Because if they were the same, they would all be beautiful, right? It just so happens they have about the same refractive index. And so we don't see the line very clearly, but the beads allow us to see where that boundary is, right? You'll notice that these things are going to start to travel up as you look at it. I can start to see little, other than the little plastic pieces floating in it from the decomposition of the bead, you can kind of see the phases separating in the water, and it's a little clearer at the top and it's murkier, right? So as that occurs, we can really see what's going on. Okay. So again, why is it important that we have a thorough understanding of the scientific method?
Because we'll use it for the rest of our lives.
Okay, but why is that important? Let's say you ended up not being a chemistry major. Say you end up going over and being an English major or a literature major. Why is it important that you have a good, thorough understanding of the scientific method? Why is it important that in your college education, look at colleges across the nation, across the globe, they will always require students to take at least some science? Why is that? Critical thinking. Yeah. What else? We want you to be able to pursue the truth, right? You are going to be, especially today, you all with the small screens that we have in front of our face all the time, are being bombarded with information and opinions and a bunch of baloney most of the time, right? Why is that important with what we're living through right now? We're going through a pandemic, aren't we? And you hear all kinds of stuff on both sides. And you have to determine for yourself what is largely believable. That's the scientific method. It's the only thing that we have that we know allows us to try to get at the truth. There is no other method out there that works as good as the scientific method. Why is the scientific method as old as Aristotle? Because it works. Okay? It works. We have found nothing better to replace it. Okay? But it starts with good observation. Good scientists always start with observation. If you're not an observable person, it will be very difficult for you to be a good scientist. For those of you who are thinking about going on to medical school, how does the scientific method relate to you? I've had physicians tell me, we're not scientists. Baloney. Somebody walks into your office and they tell you that they're not sick. How would you go through the steps of the scientific method? What would be the first thing that you would do? You would talk with them. You would start to make observations, right? Hey, doc, I'm sick. I don't feel very well. You don't go there and then say, oh, well, just take 2 aspirin and call me in the morning, right? You ask questions, you probe, you observe. Right? You better make good observations. If you make the wrong observation, people can die. Right? If you're worried about my ingrown toenail while I'm in there having a heart attack, I'm going to be pretty upset with you. All right? You got to make the right observation. From that, you're going to formulate some questions that you ask that patient. You're going to get some more information. You may research it a little bit. Now, in the office, you may not be there going, oh, let's look in the medical journals, right? But you will be keeping up with information coming from the CDC, the State Health Department. You'll know if the flu is running rampant. You'll know, are COVID cases spiking? Are they going down? Right? And then you're going to form a hypothesis. Do doctors call it a hypothesis? No. Pardon? A diagnosis. Are all diagnoses correct? No. But they are nothing more than a hypothesis. This is why we say doctors have a license to practice medicine, not a license to apply medicine or to do medicine. It's to practice medicine. So a hypothesis is like a diagnosis. Now, your patients would not want you to say this to them, but you're going to perform an experiment on them. What is that? You're going to prescribe some type of treatment. Right? So you come into the doctor's office, you're not feeling well, you're running a fever. If I was a physician, I would make a diagnosis. I think you might have the flu. Right? Now, how can I test that hypothesis? Okay. Right? So there's the possibility of prescribing a treatment. There's also the possibility of doing a diagnostic test in many of these cases. Right? So I think you might have the flu. I tell the nurse to come in and run a flu test. The test comes back and it's negative. I'm not going to just send you home. right? I'm gonna look at something else. I might draw some blood. I might do a COVID test. We might do a variety of different things. Then I might prescribe, let's just say I think it might end up being a bacterial infection. I'm going to prescribe some antibiotics, right? And then I'm going to tell you to do what? I'm going to tell you to come back and see me again. And I know that everybody thinks that come back to see me again is about getting another copay, right? But it's not. It's about following up on that experiment. If I sent you home and I gave you a course of antibiotics and it didn't get better, there's a problem that we need to address. So there's steps within this scientific method that are actually iterative. It's not 1 through 7 and you're done. Right? You do an experiment. That experiment then can then lead to new observations that allow you to refine your curiosity and your questions and allow you to get to better analysis and conclusions. As a physician, will you report the results of your experiments? Of course you will, right? People have records, that gets reported, they will know. Quite frequently, doctors are required to report the results of things without identifying who the patient is to things like the CDC. Right now, you can go on the state health page and you can determine what the cases are, right, in Mississippi. That's important for us to know. We're using that information right now at the university to make decisions about the spring semester. Cases have been going down, so now all of a sudden they're having conversations about, can we relax certain requirements? Or do we need to beef them up in certain areas, right? It's important to report, so very, very important. So if you're thinking about going to medical school and somebody tells you you're not going to be using the scientific method, not true. All right, let's talk a little bit about ethics. What does it mean to be ethical? Morals? Okay. Are morals and ethics the same thing? They're related, but they're not identical, right? Morals can come from a deep-held belief, right, in something. It's not a bad thing that be the case. I like to think I have morals, but I also have ethics, and I also have professional ethics. Right? So, why is that important?
Because you'll apply different ethics in your professional life than you would your regular life.
Okay. Why is it important for a chemist to be ethical?
Because you never want to compromise the balance.
Okay. That's exactly right. How does ethics fit into the scientific method? Pardon?
Number 6 and 7, the conclusions in your report, maybe falsifying information.
Very good. Very good. Does that mean that everything that we read in the scientific literature is fact? No. You can do some experiments that have a fatal flaw that you didn't detect and it got reported. Okay? There are plenty of examples of where people have reported the wrong structure for a molecule. Was that being unethical? No.
I think not fixing your mistakes would be
Okay? But the scientific method allows for that to happen, right? Because I reported what I found. What I found was consistent with the information I had at the time. People can look at that and interrogate my findings. right? You will go back, if you go back in a lot of scientific literature, you will find numerous examples of where people had, significant debates within the literature. My experiments show this. Wait, no, my experiments show that. And that went on for years. The two individuals have long since passed away, but George Olah, who won the Nobel Prize in chemistry many years ago for his work on, I'm trying to remember exactly what the prize was for, but it was on carbocation type chemistry. And Herb Brown also won the Nobel Prize for his work on boron chemistry. They were notorious in the literature for having debates with one another, and even at conferences. I heard stories about Herb Brown or George Olah standing up at one another's talk and criticizing the results of the other. Debate is good, right? But the scientific method, because they reported on what they were finding, allowed for that debate to occur to where we finally got to a true understanding of the phenomena that they were studying. Okay? So, yeah, because I report my findings, right, that is a part of the ethics, right? So because if I try to hide it, that's a problem. Okay? Why else is ethics important? Y'all want to go to an unethical physician? Why not? That's right. Sometimes being helped isn't exactly what you might want, right? They have to have professional ethics to do what's in the best interest of you as an individual and society at large, right? So, ethics is very important. Professional ethics is very, very important. Right? In fact, it is so important that in the engineering community, they require their students to take a course in ethics. Why would an engineer be required to take a course in ethics? Well, I say a course. It has to be part of the curriculum. Some don't do it through a course, but it has to be within their curriculum. Ethics has to be an integral part of their curriculum. I'll tell you why, because when I get on the road and I'm going across a bridge that an engineer designed, I hope that they were ethical enough to be able to point out potential flaws and not just, oh, well, you're the boss. You want me to put the bridge here, that's fine. Well, the ground's not good enough to hold a bridge here, right? People have driven across bridges and the bridges have collapsed. Sometimes it's the fault of the engineer, sometimes it's a fault of whatever for not maintaining it, right? But one has to have ethics for this to occur. What about being a student? Do you all have to have ethics for being a student?
Yes. You have to be honest and stuff.
You have to be honest. Why? Why can't you just go off and cheat?
You're not learning anything.
That's right. What's our role as a university? Our role as a university is to prepare you for what's after. Right? Not what's here, but what's after for you. We have to equip you with the ability to think critically. We have to, with the knowledge that you need to be successful in whatever career path you choose or not choose. Right? And part of that is I have to be ethical as a faculty member, and you have to be ethical as a student. Now, do we use that term ethics when we talk about stuff for you all? What policies do we have? We have what's called academic integrity policies. It's nothing more than ethics, right? What does the academic integrity policy state? In general, I don't need the exact verbatim.
That you won't cheat.
That you won't cheat,
Plagiarize.
you won't plagiarize, which is stealing. You don't cheat, you don't plagiarize, you don't lie, and you don't help others who do. Right? That's what we expect of students. You all will be faced with temptation to be unethical. Everybody is. It's called the human condition. Nobody's above it. Okay? Why are we tempted? Is it? Is it easier? You know, I've always wondered about that because I've actually seen students put in so much effort on the cheating that if they had put that effort in on the studying, but students quite frequently do feel that it's easier. But what's the motive to cheat?
You don't want to put in the work.
You don't want to put in the work? Maybe. You may have a lazy student who doesn't want to put in the work. Do you think that's the majority of students, though, that cheat?
Maybe you're afraid that your work won't get you the grade that you want.
We've placed a society, I shouldn't say we, as in this room, but society has placed high demands on your ability, right? You're not going to get into medical school unless you have a good GPA and a good MCAT score and a good interview. You're not going to get a job with DuPont and Dow if you are, X, Y, and Z. There's a lot of pressure to perform. That pressure compounded with your other daily things, right? Some of you have to work, right? Some of you have other issues that you have to deal with. And time may have just run out. And you got a test tomorrow. And you don't feel prepared for it. And you feel all of that pressure to perform. You will be tempted to cheat. We all are. But you have to think back on ethics. You might not get caught. But even if you don't get caught, you still don't end up knowing the stuff that you need to know. You've just cheated yourself more than you cheated us, right? In the paper that you read, the gentleman who wrote that paper from Tennessee wrote a book called The Ethical Chemist, which is an interesting read. What are some issues from just being a chemist that you think of with ethics?
We talked about if someone asks you to change your findings, and then you have to decide if you can do that.
Yep, that's exactly right. What are some examples where scientists may have been tempted to change their findings that you all know of from the popular media over the last couple of decades? Pharmaceuticals. There are cases where the pharmaceutical industry has invested maybe up to $1 billion on a drug that they're running through trials, and all of a sudden, the data's awfully close, but it's not quite there. Maybe if we could just squint and look at that data a little bit harder, we could convince ourselves that maybe it's right. That's unethical. But you can understand where the temptation comes to do that. What else? You've probably heard of situations where scientists were given funding from companies. That's been a debate for a long time. Should I, as a chemist, accept money from Philip Morris to study the effects of cigarette smoke? Why not?
Because it'll be biased.
It'll be biased. Why would it be biased?
Because they're a cigarette company and they might sway your conclusion.
Okay, so we would call that a conflict of interest. It's not in their interest for me to come out and say, yeah, guess what? Surprise. Right? Can that be managed? It can. It can. And in fact, we have an entire office on this campus. It's led by Dr. Bruton, who is an ethicist. I probably should have him come in here giving this talk more than me. And he manages for us our scientific integrity. Okay? I know that sounds kind of strange. But we have to take conflicts into account. I have to report. If I was to get a night job at another institution teaching a class, I have to go through that whole process to make sure that there's not a conflict of interest. If I accept money from a company to do something, we have to make sure that I don't have a financial stake in that. So a company wants to give me $100,000 to do X, Y, or Z. That's not necessarily a bad thing, but it's a bad thing if I own stock in that company. That is a conflict of interest. Can't do that. You've heard about the situations with politicians all the time where they own stock in companies, sell it early because they got some insider information. That is not ethical.
What if beforehand you sold your stock? And then
So there are ways to manage this. That's exactly right. So you've probably heard of, and I'm not an expert on this, but I mean there are things called blind trusts, where you will quite frequently hear wealthy politicians that have a lot of stocks. They will take that out of their control and turn it over to somebody in what's called a blind trust, so that I don't know the investment decisions that are being made. The only thing is that they know that they need to try to maximize my return, and I don't know how they're doing that. So anything that I make in terms of a policy decision, we're not connected. That's possible to do. Yeah, it is possible to do. What else? Where else can a chemist run into trouble? In my job, being a faculty member, two things really mattered. And it wasn't teaching you all, unfortunately. Two things mattered for my tenure. Tenure mattered to my family. But to get tenure, I had to publish papers, and I had to bring in money in terms of grants. There's a lot of pressure right there. The livelihood of my family depends on it. Right? What kind of ethical issues could I have faced? And did face. I mean, everybody faces these.
that it's critical that you get this.
Okay?
You choose to focus on that more than teaching.
That happens a lot. What else?
Your experiment doesn't go right, and you've got money on the line, and you need to get a paper out of it somehow.
Yep. That's exactly right. So every time we got ready to write a paper, you felt the pressure of this has to get published. You feel that pressure. So what's there to protect the process from being corrupted? Peer review. That's exactly right. Wait a second. You're telling me I got to publish 5, 6, 7 papers, and I got to bring in $1 million worth of grant money? Okay. I can write papers all day long. But those papers have to be reviewed by a peer review process that I don't know who they're going to. They come back and say, yes, the science is good and this should be published. Or nope, this isn't good and shouldn't be published, right? We had to go through that peer review process. There are checks and balances in place to make sure that we do remain ethical. It's not enough just to say, I do my work ethically. Everybody is tempted with this. Every one of you will be tempted to cheat in a class at some point. You don't need to feel guilty about feeling that temptation. You need to just not give in to that temptation. That is the human experience. Okay? All right, in the last 10 minutes that we have, I need you to get out a sheet of paper. Print your name on it, your ID number. And I need for you to describe to me in, 3, 4, 5 sentences a situation in which you could find yourself in an ethical dilemma and how you're going to resolve it.
Could you repeat the question?
You need to identify a situation where you might find yourself in an ethical dilemma and how you intend to resolve it. When you're done, you can just set your paper on the table there at the end, and you can leave. I'll pick up the bottles. Thank you.
Like currently?
Yes.